So we're back, and I'm joined by a friendly partner of ours. So, what's your name and where'd you come from?
My name is Soumik Ghosh, and I'm with Scan Computers, and we're NVIDIA's elite partner in the UK, and just like Arrow. And yeah, so we're in the booth right behind.
Yeah, you're literally number 5, I
Number
think. Yeah.
yeah, right there. And we're all partners as well with Arrow and NVIDIA, and a host of other NVIDIA partners as well. So this is it's a very good place to get to know the people that we work with.
So I want to come back to your day job in a minute because
Yeah.
I love talking to people like you
Yes.
because we're kindred spirits.
Yes.
But the first thing I want to say is, so what does it take to be an elite partner? What have you gone through? What do you do? What do you sell?
Well, I think there's a whole process that NVIDIA has in place to be a lead partner. But Scan has almost a 30-year history with NVIDIA. I mean, Scan is a 30-year-old company, but almost as long history with NVIDIA. Because it started off as a gaming company, so we're selling graphics cards in gaming boxes and things like that. So as long as NVIDIA has been around, Scan's been there with them. And when NVIDIA kind of moved their journey into AI, we kind of followed along with them. So yeah, it's been a long association, and so we've been selling NVIDIA products for a long time. So, but there is a pathway to this partner qualification and lead and so on.
Well, I must admit, so if you look at Scan from old, it is very much a high performance PC. And I always wanted to own one of your incredibly super duper PCs.
Yeah.
But how did you make the transformation from being a parts? You said you followed the truck, but there's a lot more to it than that. I mean, you don't just wake up one day and say, "All right, I'm selling PCs now. I want to sell AI." I mean, what was the period? What was the transformation?
So yeah, there's a very strategic transformation there, and Scan wanted to move into enterprise, and just seeing how the world and the business was changing. Essentially, there was big data around for a while. Let's say before 2012 and so on. But we were still very much in the graphics business, and so when NVIDIA started doing this with GPUs, it was a natural course for us to go. And when we look at deep learning, and GPUs essentially were used as deep learning accelerators. They were not even used for machine learning, really. It's just even literally this year and all that they're getting accelerating machine learning algorithms, let's say, put that way. But what was common between deep learning and computer graphics and everything is they all fundamentally at the silicon level are doing linear algebra. They're all doing matrix multiplications. And that's why NVIDIA jumped on board. Their hardware was perfect for doing deep learning. It was perfect for us to go along the way. There was already lots of frameworks available out there. They were Dockerized, and so I came on board as the principal data scientist here, and we built a team around this to essentially show people who had no idea about what AI was, what deep learning, anything. They didn't know what to do with that data. They didn't even know what their problem was, essentially. And so we took our expertise in hardware, systems engineering, and we just kind of scaled it up to the next level. And so, and we partnered with a lot of people.
That's quite a next level.
Yeah, that was quite a next level. But in the end, if you keep your, it took us a while. It wasn't easy to understand. The good thing is we didn't go with the traditional HPC route. That for us was a saturated market. We didn't want to be there. And AI was opening up. We understood our domain very well. We understood what we were doing. We understood our customers who were coming in quite well. We tried to work closely with them. And we followed NVIDIA on their journey, essentially. So we were all learning. In fact, so we started with the DGX1 in around November 2016, when it was literally announced, and we bought 8 DGX1s. And we put it as POCs in the cloud for our customers.
That's quite the investment. I mean, you must have really understood what the opportunity was to invest, because I mean, a DGX1, there's a DGX2 now, but the DGX1 that's not a cheap piece of kit.
So last year and even this year, we got the AI Innovator Award from NVIDIA, so 2 years running. Wow. And the reason simply was that we saw this coming a long distance. So when Jensen was giving his talks and all, we knew what he was talking about, really. It wasn't really what you saw, but what you had to visualize coming ahead. Personally, I had a lot of experience with autonomous driving. And in the US, the US Department of Defense, DARPA, So
Yeah.
they had done this grand challenge back in 2005
So
to
I
2007.
remember that was the Volkswagen
Yeah, the
4x4 thing.
4x4
Yeah,
which
yeah,
finally won it, and that was the third grand challenge, which was the urban challenge back then.
Wow.
And so I was a grad student back then, and we were still participating as one of the competitors.
That
We
is
went through all 3
amazing.
years. And back then we were still using neural networks on CPUs, which was essentially the navigation software put in a laptop at the back of a car, which was doing that. So we knew this was all coming, we knew where this was going, and the problem then, of course, was compute as it was till the GPUs came around.
Yeah.
And so when autonomous driving took off, which when NVIDIA was really pushing, we knew where this was going, we saw where the future was coming, and we went all in.
So, what is your background? I mean,
I did my undergrad in electrical engineering, but I was also designing. I did a bachelor's thesis back then. There was a lot of work going on in the mid 90s on fuzzy logic and intelligent information systems and things like that.
yeah.
But later, I moved more into chip design and hardware engineering. So
Wow.
So I did computer science first and electrical engineering. I did chip design. I was at Rice University where we did a lot of applied physics and nanotechnology, and there was a lot of great research going on.
Fantastic. So, but today you're a data scientist.
Yes, so a lot of the things that fall under the umbrella of data science have, if you're a mathematician or a computer scientist, you've been doing it day in and day out. I heard even in the keynote people say it's ETL, so this extract, transform and load, that's just standard SQL stuff. So people who've been working with databases do this day in and day out. People who are statisticians essentially do a lot of the core work. The math that goes into whatever, so in machine learning, that's a kind of a specialized part, a specialized statistics, if you will. People who do econometrics or signal processing, statistical signal processing, time series analysis, all of the math is very, very similar. Deep learning, the math is, you do Jacobians and Hessians, basically, first and second derivative matrices all over the place.
Yeah.
And that's pretty much as far as it goes. You need to have continuously differentiable functions, and so that's why you have all the transcendental functions, you have sinusoids and exponentials, and that's where it all ends. So you need to have the first derivative and second derivative possible.
So this is why this guy gets paid the money, right? Literally, I think I mean, I like to think I'm in the know. You completely lost me then. That was amazing.
But that's essentially it. So, but the statistics, goes way beyond that. And what all the smart people Google and what they're doing is they're finding neural networks have been around for a really long time.
Yeah.
And their literature on that has been around for a really long time. And people are rediscovering some of those things at a larger scale. They're finding new problems to solve at a scale. So back in the day where you didn't have large machines to compute with, most of the problems or the research went into trying to optimize your math or make approximate math to fit the hardware.
So, here's my question to you then. What is the future of the data scientist?
Very bright.
Yeah.
Extremely bright. So let's put it this way. As long as there's this data deluge happening, you will always need data scientists. Now, how you want to define a data scientist is a different story.
Yeah.
And so the people even who just sit and do the ETL work are invaluable because somebody has to do that.
As I say, the data sort of, I mean, we sort of look at, because it's an interesting conversation I've had all over the place, is data science the data munching and the data sort of the cleansing and the tagging and all of that pre-illusion, so
Yes,
the standard ETL process essentially?
In reality, I don't know, 60 or 80% of the work is really that. So it's these old adages that, garbage in, garbage out, that always stays. So, and AI systems or machine learning systems, it's really like training your children, and that's always been the case. If you train your child watching violent movies, very likely is going to come out violent kind of a person in the end. If you teach your child your algorithm, wrong stuff, your golden data set is not good enough.
Yeah.
You're not going to learn good things. And so then you go on to build GANs, and if you're going to do all this reinforcement, you're just going to learn bad things. So your golden data set is invaluable, and you
Yeah.
always have to keep increasing and curating it and so on and so forth. And that's a lot of work.
So here's my question to you then. Another question to you. I've taken advantage of the fact I'm talking to someone really intelligent. What's more important, refining the algorithm or refining the quality of the data?
You will get a lot of mileage by simply refining the quality of your data. Now, you have to be very careful about what you do with your data. Yeah, and this is, ideally you don't want to modify your data. And you have to be, and that is, so a simple example, the difference between a null and a zero. And we see this all the time everywhere. When people do ETLs, they'll say, oh, I had a missing data somewhere, it was a null in a database, and oh, our code couldn't handle that, so I put a zero there, I put a numeric zero there, and that made my code work, otherwise it was crashing.
Yeah.
The problem is you have changed the data, you have changed the information content of your data. A zero somewhere actually means that you have that information, that something has a value of zero. A null means you don't know anything about it. And you fundamentally change the character of your data by doing something very simple like that. You cannot change the nature of your raw data. And that's you cannot change the information content. So you have to be very careful when you curate your data, when you transform your data. You have to understand very well, do you need to transform your data? How do you need to transform your data? Why do you need to transform your data? A lot of people, they will normalize, they turn things into a Gaussian, just like I will normalize somehow. Or, they will harmonize data or something. Yes, you need to do that for many statistical things, but you also need to understand why you did that. What are the implications of that? And when you try to interpret your results, you have to interpret your results in light of those transformations that you did.
Do you know what? I've not really thought about how the ETL process can actually fundamentally affect. I mean, obviously you're transforming the data, and if you modify the data, then you're going to change the outcome. But actually, to have almost an ETL process or an interpretation engine at the other end that's aware of the modifications you've made or the way that you've transformed the data to present it in a way that makes sense, that's genius.
But you have to do that. So the work of a data scientist, and that's why they are so valued, is you really, really need to understand. You're not just writing code. You need to understand what you're doing.
Yeah.
Coding is part of it, and choose your framework, choose whatever you're doing. But it's a bit of an art, and that's the thing. It's not a press a button thing. You need to understand the math that's going in, how that math applies to the domain, to the problem that you're trying to solve. You're looking for variables, you're looking for features, you're trying to see, have you done the best things? Very iterative process many times and so on. So it takes a while to do these things, but that's where the knowledge and everything that a data scientist brings comes in. And but then those are also things these days with AI, the algorithms are learning to do. So case in point is H2O driverless AI and things like that. So they are essentially saying, we get rid of the data scientist from the loop altogether.
So that was so going right back to my question, what's the future of the data scientist? Is the data scientist going to be, well, first and foremost, I actually really like your definition of a data scientist. I think a lot of people define the data scientist as the person who does the algorithm. But actually you're saying, no. Refining that data is not, because a lot of people I think, oh, well, that's a task that's probably too high-end for an expensive resource like a data scientist.
Yes.
But actually, you make the argument that that's exactly where the data scientist should be.
It should be, yes. And because you can develop an algorithm, and that's really the fun part. You make a new algorithm, refine an algorithm, find a new trick to do something. Yes, that's a lot of fun. But in the real world, when you actually have to take real-world data and make a real-world application out of it, the fun math part has roughly been done. You now need to understand how to apply that to the real-world data and how to make sense of it all. And you need domain expertise, you need to bring in domain experts, you need to yourself understand this data, what transformation really makes sense, doesn't make sense, what algorithm, supervised, unsupervised learning, it's a whole world of things to understand. I mean, and not just know, but really understand why you're doing certain things.
Awesome. Well, look, Soumik, we could literally talk for hours, and I think I may well get you onto our main Arrow Bandwidth podcast, and we literally can talk for hours about this. But no, thank you ever so much. Really appreciate you coming on. And well, have a good rest of your expo.
You too.
Thank you very much. Cheers.